Hi guys, I just realized that I made a mistake in the solution of the last question. I found the monotone likelihood ratio statistic as summation xi square, but actually L is not a non-decreasing function of summation xi square, it's a decreasing function. So I want to correct my mistake and let's solve the question again. Sorry about my mistake. So on that question, our PDF was given as 2 theta x e to the minus theta x square, where x is greater than 0, theta is greater than 0, and we had a random sample of size and the hypothesis is given as theta greater than theta 0 versus alternative is theta less than theta 0, and we want to derive the uniformly most powerful test of size alpha. Okay, so we want to derive that. First of all, we have to find the likelihood function under the condition that theta greater than theta 0 greater than theta 1. So L theta 0 over L theta 1. This part is the same. So we had 2 and theta 0 to the n multiplication of xi theta summation xi square divide by n theta 1 to the n theta 1 xi square. So these two values cancels out, and the simple likelihood ratio is defined by theta 0 theta 1 to the n, and we have e to the minus summation xi square theta 0 minus theta 1. So I made a mistake at this point. So this quantity under the condition that theta 0 greater than theta 1 case, this part is greater than 1, and so here, so combining with this minus sign, basically our e function is negative, right? And then this means that L is a non-decreasing function. Sorry, so L depends on sample random variables x1 to xn only through, that part is the same, summation xi square, and L is we can say decreasing function or non-increasing function of summation xi square. So this means that our monotone likelihood ratio statistic is minus summation xi square. Okay, and then after deciding that our uniformly most powerful test is reject H0 if r minus summation xi square at this point we have to look at the direction of the null hypothesis. It is less than theta 0, so we have to say less than c. Now we have to find the value of c again using the distribution of summation xi square. That part is the same. Remember we did a transformation and show that this was exponential with 1 over theta parameters. Yeah, it should be like that. And then when we consider summation xi square, then it should be gamma and 1 over theta. Okay, so basically here the rejection region, we defined our rejection region as this, but this means that actually our rejection region is greater than minus c, or we can say, let's say let's say d. Okay, okay, then again using alpha, we given information probability that sorry, there should be a square, summation xi square. Now forget the equalities, greater than or equal to d, let's say, where theta equal theta 0. Again turn this to a chi-square random variable by multiplying it by 2 theta. So 2 theta 0 summation xi square greater than or equal to 2 theta 0 d given theta equal theta 0. After defining the distribution as chi square with 2 and degrees of freedom, you don't have to write the given part. So at this point we have to find this quantity alpha. So again in the PDF of the chi-square with 2 and degrees of freedom, we have to find the value of chi-square where a lower bound is 2 theta 0 d and the probability is alpha. So we are talking about upper tail probability. Okay, so this part is alpha and this point is 2 theta 0 d, and we know that it is actually chi-square 2n with alpha. We are using a right tail probability in the representation of the table values. So this means that RD is chi-square 2n alpha over 2 theta 0, right? Then our uniformly most powerful test of size alpha is reject H0 if summation xi square greater than or equal to RD, which is chi square 2n alpha over 2 theta 0. Okay, after that, basically in the second part of the question, when we want to find the power function, so we are using the same terminology. Please don't write C here, okay? So write the or D, write the value that you found actually. So this is our test given theta. Okay, so for any theta we can do that, or theta 1 let's say. So let's put 1, and now our true theta value is theta 1. So multiplying with 2 theta 1 summation xi square make it a chi-square random variable. So 2's are cancels out and we have theta 1 over theta 0 chi-square 2 and alpha given theta 1. Then after defining the chi-square random variable, then I can calculate this quantity from the chi-square table. So this is the power function. Sorry about my mistake.